This is AP Review, and it's 2010 Form B, AB for Response 5. Consider the differential equation dy dx equals the quantity x plus 1 on top of y. Time out. Before we do anything else, this is separable. The y can be divided or multiplied over to this side. The dx can be multiplied to this side. So this is definitely something that at some point you're going to be asked to solve. Okay, moving on. On the axes provided, sketch a slope field for the given differential equation at the 12 points indicated. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Cool. And for the window from -1 to 1 for the x values, sketch the solution curve that passes through the point 0, -1. And that's the thing a lot of people are going to forget to do, so we need to pay attention to that instruction. So how much work you need to show on a slope field depends a lot on you personally, right? So if you want to make a list of what all the slopes are, that's great, right? It's entirely up to you, right? So notice that y equals 0 was removed from all these because that would make this undefined, right? So if you want to list all the points, right, like x, comma, y, and then find what the slope is, which would be x plus 1 on top of a y, that's fine, right? If you don't need that, if you can do it in your head, that's also great. I always start bottom left and work my way up. I don't know why. This is -1, -2, -1, -1, -1, 0 is not a point, -1, 1, -1, 2, right? And then 0, -2, 0, -1, 0, 1, 0, 2, right? Because all the 0 y values are gone. And then 1, -2, 1, -1, 1, 1, 1, 2, right? So and then I'm going to go ahead and find the slopes. Again, how much work you need to show on this is up to you. What I want you to notice is that for all the x values that are -1s, this is going to be a 0 on the top divided by a non-zero number because they specifically left out y as 0. So all of these slopes are going to be zeros, right? When I plug in x is 0, I'm going to get a 1 on top. So this will be a -1/2, a -1, a 1, and a 1/2, right? When I plug in 1, I'm going to get a 2 on top. So 2 over -2 is a -1. 2 over -1 is a -2. 2 over 1 is a 2. And 2 over 2 is a 1, right? So, and then I'm going to sketch my slopes. So if I were you, I would sketch the 0 slopes first because the AP definitely looks for them. So all of these slopes are zeros. And that's probably worth a point, like all of the 0 slopes, right? And then I'd sketch all the other ones, right? So at this spot, 0, -2, I should have a slope of -1/2, which means down 1, right 2, so aim like there, right? Then -1, which means down 1, right 1, so aim there. Then +1, which is up 1, right 1, so there. And +1/2, which is up 1, right 2, so slightly flatter than that, right? But still positive. At 1, -2, I should have a slope of -1, which is down 1, right 1, so there, which is the same basic slope as this guy. Those are both -1s, right? And then I did a bad job of drawing it, but those are the same slope. And then at 1, -1, I should have a slope of -2, which is down 2, right 1, so that's also pointing there, right? And then I should have a slope of 2 here, which is up 2, right 1, so that's steeper. And then another slope of 1, which is the same as this slope, so those should both be slopes of 1. Cool. All right, so that's also probably worth 1 point. Then I have to do the thing that they mentioned that I have to be careful not to forget to do, which is draw the solution curve through the point 0, -1. So 0, -1 is right here. Sorry, not what I meant, is right here. Come on, brain. I ruined my green pen a little bit. So 0, -1, my bad. So notice that these all have a slope of -1, so this is just going to be a line. And it's going to be a line all the way back up until here, but not actually including this spot, because they said don't include the x value of -1, right? So it's going to be a line that essentially looks like this, and dead ends right here where the slope is undefined. Cool. So, part B. While the slope field in part A is drawn for only 12 points, it is defined at every point in the xy plane as long as y does not equal 0. Describe all points in the xy plane where y is not 0, such that dy dx equals -1. Cool. So, in part B, so that was my part A, right? Oh, and this was the third point, by the way, was drawing the line. So, part B, they ask me to set dy dx equal to -1. Right, and to describe those points. So that's the same thing as saying x plus 1, right? over y equals negative 1, or x plus 1 equals negative y, or y equals negative x minus 1. So essentially, it'll be all points on this line as long so except the one where y equals 0, right? So it would so essentially it would be every point on this line except so that would be the point negative 1 comma 0, right? So it's every point on this line except that. So it's really this solutions curve that they just gave us. It's every point on this line, right? Every point on this line is going to have a slope of negative 1, except this one point where the slope is undefined. We should have anticipated at the beginning of this problem, because this is a separable differential equation. So we're going to separate the variables. We're going to multiply the y over to be with the dy, and we're going to multiply the dx over to be with the x plus 1, right? And then we're going to do the antiderivative of both sides, right? I'm going to integrate both sides and get y squared over 2 equals x squared over 2 plus x plus c. Now, the way they phrased this, they said to find the solution y equals a function of x, right? That is code for solve for y, right? They also gave us that f of 0 was negative 2. So they also gave us f of 0 is a negative 2. So that is what we use to find c. All right, so at this point, we've done all of the, we separated our variables, we found the antiderivatives, we included our constant of integration. We have 2 jobs left, and it doesn't matter which order you do those 2 jobs, but you have to both solve for y and plug in to find c. Cool. So I don't care which one you do first. So if I choose to plug in first, so if I choose to do this first, right, if I plug in to find c, I'm going to get that 4, because negative 2 squared is a positive 4, over 2 equals 0 plus 0 plus c, so 2 is my c. So now I get y squared over 2 equals x squared over 2 plus x plus 2. And now, so I've done this, I'm now going to solve for y. So I times everybody by 2, and I get y squared equals x squared plus 2x plus 4, right? And when I go to solve for y, I'm going to take a square root. When I take a square root, I have to write plus or minus. So I'm going to get x squared plus 2x plus 4, but that's not my final answer. It's one of these 2 options, not both, because remember, y can't be equal to 0 in this differential equation, so we're looking at a graph that is either the curve above that line y equals 0 or below the line y equals 0, but not both. So I look at the solution they gave me. They gave me negative y values. So if I plug in 0, I'm supposed to get a negative 2 out. The only way that happens, so since f of 0 is a negative 2, the only way that happens is if this is the negative case. So y is the negative square root of x squared plus 2x plus 4, and that's the answer they want, right? Now, if you had solved for y first, you totally could have solved for y first, and then as long as you noticed the negative thing, figured that out, and then plugged in to find c, totally fine.